Now, these are a few questions about buses and about transmission of data inside the computer. And so the first one we've got here is a diagram. All we have to do is name the bus that's labelled X here. And we can see that there's a one direction line coming from the processor to that bus. And then there's a single direction line again going to memory. There's a single direction line going to the input-output controller. So because of the idea of one direction only, we're putting addresses onto the bus. So it's the address bus. So we're putting addresses onto the bus from the processor, and we're using those addresses to locate an area in main memory or locate the memory of a device from the I/O controller. So therefore, that one's the address bus, and you can always identify the address bus by thinking about the single direction. If you look at the other two buses, they're all both directions. So we've got a data bus which carries data, but we might need to read and write data, and we've got a control bus that takes signals from the components and uses it to control devices such as the input-output controller. So that's the address bus. So then the next question up here, the data bus inside the computer uses synchronous parallel data transmission. And we just need to describe what synchronous transmission is. So parallel is obviously lots of wires sending data at the same time. If we've got a synchronous system, then the components that we have need to share a common clock, or they're synchronized all the time by a common clock. So because it's inside the computer, we probably refer to components. So we could say components receiving and transmitting share a common clock. So when you've got a question like this, it's always worth talking about the receiver and the transmitter, if you like. In this case, it's receiving and transmitting components because it's inside the computer, but if it was two devices that were not necessarily both inside and they were both showing a parallel synchronous, you could say the sender and receiver or something similar, receiver and transmitter. Just saying components share a clock is not going to be enough. So if you just say the components share a clock, you're not going to get that, I don't think, but you definitely get receiving and transmitting components share a common clock. So all that means is that the clock signal is sent alongside the data. So both components are permanently synchronized. So this is not like asynchronous communication where the clock is woken up and then synchronized for a short period of time. So they're synchronized all the time. So this is a common mistake when people answer a question like this, is they think about asynchronous and not synchronous communication. Okay, so we've got one more question down here to have a look at, and this talks about the USB interface, and it says it's an example of an I/O controller, so an input-output controller. So we need to describe the role of an I/O controller. The most common answer to this is it allows you to connect something to the computer, or allows the computer to use a device. It's not going to be enough. We need to talk a bit more about the specifics of how this works. So we could say that this allows the processor to communicate with a peripheral any device will do really. Using an I/O port. So that bit's really important that we say I/O port. So an I/O port is essentially just the bit of hardware that you're plugging something into. So you're plugging a device into the input-output port, and that allows communication, and it translates signals basically. So it translates those signals, so the data that comes from a peripheral is translated into something that the processor can understand. So we could say it translates signals from the device, perhaps we should say to something the processor can understand is okay, I think, in this case, or processed, use, process, something like that. I don't really like the word understand very much because computers don't really understand anything. They're not sentient at the moment. So there are other things we could say about this. The input-output controllers also have a buffer. So I/O controller has a buffer. And that buffer is just a bit of memory. And that memory is used to temporarily hold some data when it's being sent between the computer and the device, so that there's nothing lost. So it just holds it briefly. It also means that we could, if we go back and look at the question again, because we've lost it now, there it is. So it also means that we can add new devices because the I/O controller can be used to do the translation for us, so the processor doesn't have to know about every single device that is possible to put into the computer. So actually, you know, some devices might have been created after the processor in the computer, so you don't have to redesign the whole processor and the whole computer hardware to use a new piece of hardware, a new peripheral. So there are several things you could say about this, but really the easiest thing to remember is that it allows communication with an input-output port, you must say input-output port, and translates signals between peripheral devices and the processor so that it can interact with and understand, or not understand, but it can read the data from the peripheral device. So that's just one or two questions there about the internal hardware of the computer.